Jai Hind everyone. I am Ashish Dixit, Assistant Professor, Computer Science and Engineering Department, AKGEC Engineering College. So, today we are discussing about the topic single linked list. It's also considered under the data structure using a C and also running in a AKTU. So, here we will consider some topic linked list outline and why linked list use, what is the linked list, what is the representation of the linked list, traversing a linked list, memory allocation, garbage collection, and in which condition it's a overflow and underflow. And we will also focus on some operation like insertion, find, deletion, print, etc. So after the singly linked list, we will focus on a circular linked list and doubly linked list. But here we will discuss about the singly linked list. So before the singly linked list, we will discuss about the linked list. Why linked list use? Because the main disadvantages of array are storage data structure, because it's also insertion, slow insertion in an order array, and also provide only fixed size. But linked lists solve the sum of these types of problems, and it's also used for a general purpose data structure. Okay. Then definition of the linked list is it's a list or a collection of data items that will be stored in a scattered location in a memory, because many nodes also scattered in a different form. So through the link we will connect it with each other. And second method, to store a data in scattered location memory, so we have to make a link between one node to another node. And next part, a node that have two types of field. First field is a data part, and second field a link part or a address part, or that's why we call the next. Okay, so link part is similar as a address part is a similar as a next. Because, and second thing, each data item of linked list is called a node, and data part contains hold actual data, means item, or we call the information, and second part also have the address of another node. This is called a link part points. That's also show the next node of the list. Second thing, this is the locate to list, an external point is used that points the first node of the list. The link part of the last node will not point any node, because the last node don't have the address of another node, because it's a last node, and last node also have a null value. In address, it's also have the null value. Next point, this type of linked list is also called linear one way. Means one way, it's also work on a two way or a one way, but here we will discuss about the only one way. This is called a singly linked list or a simple linked list. Okay, so here a single node of the linked list. Single node of the linked list. First of all, how to declare a structure of the node using a code. So here this is a node, and this is the information part. And this is the next or pointer part. So here we will create a node structure, struct node, and it's a structure of node. Here two data items are also available, two field is also available. First is called data and second is called next. This is called a pointer, and the data is also called variable for data part, and next is also called a variable for pointer part. A pointer that will point the next node, means it's also have the address of another variable that will be point. Suppose that this, it's also have a 5 and its address is a 101 and its address is a 102. This address is also hold in this location. This is called next, means next value hold the address of this node, means this is a node and this is the B node. I think you well understand. Okay, so here it's a graphical representation of the linked list. So it's a single linked list, that's why here we will represent how to represent a graphical representation of the linked list. Here it's a one node. Suppose that it's also have the address 101, 102, 103 and 104 and 105. First node that's also hold the value or item. Then it's a second part, this is called next. Next also hold the value, the address of the another node. Okay, and this next is also hold the value, address of 90, and this node also have the value 104 in the form of address, and this is also hold the value of the this node. This is the also the address and it's a next value, and this node also have the null value, because after this node no node will be available, that's why it's called a null. So first of all, this is the pointer that point the next node, and this is the external pointer that point the list and the value. Okay, how to store a data in a node? So here we will discuss about the how to store a data in a node. So first of all we will declare the node declaration, then how to store a data. So here suppose that it's a node, and it's a node, then create a structure, it's a node. Okay, in this part we have a data, and in this part we have the next, then structure of the node, then also have the integer type of data, and node means the value of the next node. It's also considered through the pointer, because a pointer also have the address of the another variable. So here pointer, next type of pointer also hold the value of another node. Okay, next thing, how to store a data, means this node how to store a data. Suppose that it's a node, and it's also hold the value 20, but in a next part it's also have the null value. Okay, so first of all, node ptr, we will declare the node ptr, then nptr, node nptr new pointer. It's called a new pointer and declare through the pointer nptr. And nptr is also hold the value of the new node. It's also called new node because first of all declare a pointer, then second thing allocate a space in memory. How to allocate a space in memory? Second thing, new pointer also have the data. New pointer also have the data. The new pointer also have the data 20. Then here data of the new pointer is called 20 and next of new pointer, it's a new pointer, next of the new pointer is null. So next of the new pointer is null. Okay, here assign a null to a pointer value. Got it? Okay, create a new node. How to create a new node? Here we will declare how to create a new node. First of all, node declaration, I already discussed about this. Then structure, int, data, node, next and term. Then declare a variable. How to declare a variable? Node, pointer, new pointer. Allocate a memory for a new pointer, new node. New pointer is equals to new node. And how to enter the value in a new pointer? Then new pointer also have the data, means item. This is the item and this is the next. Here next is also null. So here new pointer, it's a nptr. New pointer also have the item. So new pointer, a data is also have the item and new pointer also have the data and data is also related to item. And next of the new pointer is null. Next of the new pointer is null. Okay, got it? Next, a linked list creation process. How to create a linked list? How to create a linked list? Means suppose that in a field we have a pointer and it's also link another node. Okay, now how to link with each other? This is the creation. So here create an empty linked list. How to create an empty linked list? Maybe in a memory field it's only one node that's have a no value or null. Means if linked list is empty, then how can we say that? That means the external pointer will be null. That means external pointer will be null. Second thing, create a new node. How to create a new node? First of all, the data part of the new node will be contains a data. Means if any item, any node have a in a memory field, then here it's the information part and it's a next part. So here we will consider data part of the new node will contains the data. This is the data and also called information, and the pointer part will contains the null. Then here this is the pointer and pointer parts also have the null value. Then second thing, the external pointer will point the new node. Suppose that one external pointer is also available, then this point only one node in the list. Okay. Second thing, create another new node and include the node to the linked list. Suppose that here one node also available, then second, then third, and after the connectivity these are connected with each other. Then create another new node and include the node to the linked list. Got it? Then this process repeat a continue order whenever we will find out the null value. Okay, next part. here creation process. So here, first of all, create an empty list. I already discussed about this. This is the list and this have a no null value. This have a only null value. Then list also null. Okay. Second thing, create a new node with data. Create a new node with data. This is a new node and this is called a new pointer. This is called a new pointer. Then how to create? Then new pointer is equals to new node and nptr new pointer also have the data. Data is 40. Then here new pointer also have the data and data is 40. Second thing, this new pointer also have the next value and next value is null. Next value is null. Okay. So here also declare the next of nptr is equals to null. Third thing, include the node into the list. Suppose that we want to include some another nodes, then list of nptr, list of new pointer, and after this next node is a tptr. Then tptr is equals to nptr. Next thing, tptr is a temporary pointer used to make link between existing existing list and new node. So here linked list creation process, how to create a new node inclusion. You see about this. This is the first node, this is the second node. Okay, this is the list. Then here temporary pointer and new pointer. So here we declare about the nptr equals to new node. Then nptr, data of the nptr 48 because it's a new pointer, and the value of the next of nptr is equals to null because here is a null value. Okay. Then suppose the next node is also included, then how it will be declared? It's a first node pointer and it's a second node pointer. It's a first node pointer tptr, yani temporary pointer. Temporary pointer, it means next of temporary pointer is nptr. Suppose that this is the temporary pointer, suppose that this is the temporary pointer and it's also point the address. Then temporary ptr, then suppose that temp ptr also hold next is nptr. Then tptr, next of the tptr is equals to nptr and tptr is equals to nptr. Okay, means tptr is a temporary pointer used to make a link between existing a list of a new node. It's a graphical representation. Okay, it's a graphical representation. We shall enter a data in ascending order and create the list. Suppose that this is the list and first item is a 40, second item is a 48, third item is a 59. Okay, and we want to insert a one node in a linked list 40. Then before the link of this node, first of all we will declare that this is the tptr, this is the temporary pointer and this is the new pointer, and here we will put the address of nptr in this location. Means next of tptr also have the address of nptr. Got it? Suppose that nptr also have the 103, then 103 is also here. Okay, then next of tptr also have the address of this node. This node, the value is, means address is 103. After the addition, the list will be create 40, next of 40, means suppose that it's also have the 101, 102, 103. Okay, Then here, the next of this node, and next of this node is this node. Then here we will declare the next of the temporary pointer. Next of the temporary pointer is NPTR, means next of the temporary pointer is NPTR. Okay, and here TPTR is equals to NPTR. Before the insertion, it's a TPTR, it's NPTR, but right now after the link, it's a TPTR, because NPTR also will make like a TPTR. Okay, got it? It's a pseudocode. Here we also discuss about this code. So I think every node will understand. Declare a node. It's also discuss about this. Create an empty list. List equals to null. We will already discuss about this. And create a new node. It's also discussed. And make a link between the linked list and the new node. First of all, here we will check about if the list is null. If the list is null, then list equals to NPTR and TPTR is equals to also a NPTR. Then else, suppose that list is not null, then what can be done? Then here TPTR, next of the TPTR is equals to NPTR, and NPTR is also equal to TPTR. So new pointer is also work like a TPTR, temporary pointer. This process is repeat step 3 and 4 unnecessary times and adds more nodes. Then after, output linked list will be available. It's a second thing, how to search, search or locate a node of a linked list. Search a node of a linked list. Suppose that here linked list is also created and here is a 51. I want to search a 51 in a linked list. Okay. The main problem is that find out the item 51 from above linked list. All items in the list were sorted in ascending order. And to locate the node, we have to traverse the list using a pointer. How to traverse the list? Through the using a pointer. And we have to also use a temporary pointer to traverse the list. And second thing, each node we shall compare and check whether we have found the node or not. Got it? Here, this is the list. Suppose that it's a linked list, it's a temporary pointer, and we want to search a data 51. So how to search the data? Given a condition, temporary data, data of temporary is equals to 51. Suppose that in a general way, it's a pointer. First of all, it's search a, it's a 41. No. It's a 51. No, it's a 21. Okay. Second thing, 45 is equals to 51. No, sorry. And second thing, it will be get. Then TPTR data is equals to 51. It's a match. Then what process will be available here? Here process is available like a temporary data tends to data is also 51 or not. Means we want to search a 51. First of all, we check the inner information part 51 is available or not. How to search a data? First of all, temporary data is equals to 51 or not. Here condition will be applied here. Then second thing, TPTR is equals to TPR, TR next. This process is first check a node. If node is not available, means data is not available, then it's also switch to another node. Then again check. through the temporary data to data is equals to 51, and also provide the temporary node, temporary pointer, also indicate the next node. Here, algorithm to search a node from linked list. How to search a node from a linked list? It's also code available here. Suppose that we write algo, define a variable item and pointer TPTR. It's a item, it's a pointer. Okay. What is the item? Item is a 51 because we want to search 51. Got it? Okay. So here input the value to be located. Then again search the item. Search the item through the TPTR. Okay, temporary pointer. If the list of the temporary pointer is also available in a 51, then first of all it will be searched. Then here we will apply the condition while data of temporary pointer does not equals to item and next of temporary pointer does not equals to null. Whenever its condition will be run, then one pointer, one node to another node, it will be searched in a continue order. Whenever we will not find a 51. Okay. Then first of all, in a loop, we will run this code. Next of the temporary pointer is equals to TPTR. Means first search this, then this, then this. This process will be continue order. Then after, if any node will be find, then out of the loop and declare if TPTR, data of the TPTR is equals to item, if 51 will be find, 51 will be a 1. Okay, 51. Then it will be found. Otherwise, not found. It's a very simple. Second thing, how to insert a node into list. Which types of technique will be applied here? Because node will be inserted in a 3 location. One is the first location of the linked list. Second is a between a mid position of the linked list. And third is a last item in the linked list. Suppose that. So here we will apply different types of techniques. Suppose that here it's a graphical view, it's a new node. New node is a 55 and existing linked list is a this. It's also have in a ascending order 40, 48, 59 and 63. And here we want to insert a new node 55. Okay. How to insert this node between an existing linked list? So here we will follow this process. 55 in a ascending order, here we will apply here this node, it's a new node. It's mentioned through the NPTR new pointer, and before this pointer, this is called temporary pointer. This is the temporary pointer and this is the new pointer. Okay. So here this node will be add here and we will find out the this node NPTR next of NPTR is linked with this address. Okay. And next of TPTR linked with this new pointer address. It's a chances. Okay. Okay. So here we add a 55. It's a new pointer and it's a temporary pointer. Okay. So here we will add this pointer, new pointer with temporary pointer, and we will create a new link, new list. (40), 48, 55, 59, then 63. Okay. This process. So here whole process will be applied here. Assign the value of the external pointer. Which types of steps will we follow here? First point, assign the value of the external pointer to our temporary pointer like this. Then second thing, compare the value of the next node with the value of the new node. Here old node and new node will be compared here. Then traverse the temporary pointer until we find. Unless we will not find the exact location, then it will be traverse. Okay. So here which way it will be traverse? Temporary pointer is equals to tptr next. Then this process, then this process, then this process, then this process is also maintained here. Okay. So how to insert a node between two nodes? So which types of code will be available here? We will discuss about this. Suppose that temporary pointer is 48, have the 48 value. Okay. Suppose that it's also have the address 101, 102 and 103. Okay. Before the insertion of this node, this temporary pointer have the address of this pointer, and 101 also have the value 103 in this form. Okay. But after the insertion, what will be happen? First, point the next node by the new node, means new pointer next of the new pointer, means next of the new pointer, this next of the new pointer is equivalent to next of the temporary pointer, means next of the temporary pointer is equal to the next of the new pointer. So here will be mentioned nptr next equals to tptr next, means both are same. Second thing, point the new node by the previous node. How to declare a previous node? Then here tptr next of the tptr is equals to nptr next of the temporary pointer. Right now it's a nptr, means next of the temporary pointer is right now nptr, means before this the next of the temporary pointer is this, but right now this new pointer hold the address of this pointer. Okay. That's why we will declare about the next of the temporary pointer is right now is a new pointer. We have a got an updated linked list. Got it? Let's see. It's a graphical review. Here this is the linked list and this is the new node, because we want to insert a new node. New node we will declare through the nptr new pointer, and before this is the tptr, because we want to insert this node between 48 and 59. That's why here we will declare here. So first of all, if we want to insert this item, then firstly the address of nptr the address of NPTR is also have the address TPTR, means the next of NPTR hold the value of this node. Okay, means suppose that 101, 102, 103 and 104. This value is also hold 103 in this node. Okay, and suppose that this is also have the 106, doesn't matter. And this address is also hold by the temporary pointer, it's also 106. Okay, so here we will discuss about this. New pointer, next of the new pointer attached with this pointer, and next of the temporary pointer is also attached with new pointer. Then after declaring 40, 48, 55, 59 and 63, and 55 will be 55 inserted in this linked list. Okay, it's a updated result. Got it? Here algo is also available. Please, it's an algorithm. Input linked list, we have to use an existing list. Declare pointer. Which types of pointer will be available here? List, temporary pointer and new pointer, because temporary pointer is also equivalent to list. So create a new node. New pointer is equals to new node. The new data of the new pointer is equals to item, and next of NPTR new pointer is equals to null. First of all, we create a new node. Okay, then second thing, locate the appropriate position for the new node. How to search that in which right location we will insert a new node? Then first of all, we will find out that while data of temporary pointer is less than data of new pointer, means this is a new pointer and this is the temporary pointer. The temporary pointer, data of the temporary pointer is less than data of the new pointer. That's here. That's why here we will apply a loop. Then temporary pointer TPTR is also written like a TPPTR, and TPTR next of the TPTR is equals to TPTR. It's a variable, so no matter will be available here. Any confusion? Then next of the new pointer is equals to next of the TPPTR. Then because it's a previous node, then here next of the TPPTR is equals to new pointer. Then this process, because here two processes also available, means a temporary pointer and a previous pointer. Okay. Next method, next operation, deletion of a node. So always kept in mind, deletion will be also apply three way. First of all, we want to delete a first node of a linked list. Maybe we want to delete a node that will be exist in a between the linked list. And third thing, maybe we want to delete a node that location is last in a linked list. Okay. So here we will also available some steps. So here declare some steps. Use a temporary pointer and assign its value of the external node. Temporary pointer is equals to list. Second thing, compare the value of the node pointed by the temporary pointer and the value of the node to be deleted. Maybe if the first node is target node, maybe a linked list that have only one node, or maybe first node. If the first node in the target node, then we will found the node, otherwise nothing. Second thing, assign the value of the temporary pointer to another pointer. So save the value, means previous pointer is equals to temporary pointer. Third thing, traverse the temporary pointer node until we locate or find the node, means next of pointer is equals to tptr. So here we will establishing the pointer, previous pointer and temporary pointer. It's a representation. Suppose that we want to delete 55 in this list, then this is the existing list. Here search, first of all we create a search 40, 48, 55, 59, then 63. Here we find out the 55. This is a temporary variable. Okay, this is the previous pointer, this is a temporary pointer, and if this is the deleted from this, then this previous pointer also have the address of this pointer, and this pointer will be deleted. Okay, then deleting the target node 40, 48, 59 and 6. So here this is the algo. Declare a pointer, list, temporary pointer, previous pointer, input linked list and the item that is to be deleted. And here we will search about this temporary pointer in a list. Here we will apply the condition and check the item. Then temporary data does not equals to item. Check. Then this process, previous pointer is equals to temporary pointer. Then next of the temporary pointer is equals to temporary pointer. Then delete the node, and previous pointer next of the previous pointer is equals to next of the temporary pointer, and delete the temporary pointer, and this is the output. After this we will find out the output. Thank you everyone.